Alright, so let's talk about Xbar and R charts in the measurement system analysis. In a previous lesson, we used the components of variation graph to look at different sources of variation in measurements collected from the PCBI viewer measurement tool. So let's continue the graphical analysis of the results by evaluating Xbar and R charts. These charts will help us analyze part-to-part variation and the repeatability of the measurement system. Remember, some variation is always present in the measurements because the operators are measuring different circuit boards. Ideally, the variation between paths is much larger than the repeatability variation, or how much variation exists when the same operator measures the same board. On the Xbar chart, this is seen when most of the points are outside of the control limits. So let's look at the Xbar and R charts more closely for the data collected from the PCBI viewer measurement tool. So first, we'll evaluate the repeatability of the measurements using an R chart. Remember, repeatability is the variation observed when the same operator measures the same path with the same device multiple times. The R chart plots the range of measure values for each combination of path and operator. To illustrate, here are operator 1's measurements on the first board. The range of the four measurements is 0.01182. So, and this is the first point on the R chart. The range of operator 1's measurements on the second board is 0.01594. This is the second point on the R chart, and we continue this process for the rest of the boards and again for the rest of the operators. Because there are 5 operators and 12 boards, so a total of 60 points is shown here. And next, we add a center line and control limits. The mean of the operator ranges is 0.01545. So we call this the value R bar, and plot our center line here. Next, we add the control limits. The upper and lower control limits represent the amount of variation we expect to see if the operator ranges are stable over time. For the PCBI Pro operators, the upper control limit is 0.03524 and the lower control limit is 0. We can use the R chart to detect variation in the operator's measurements. So if any points fall outside the control limits, then that operator has difficulty consistently measuring the same circuit board. So do all of the operators measure the board consistently? Is the answer yes? No, that is not the answer. Okay, so let's take a close look at the measurements for the operators 3 and 5. Okay, and the answer is no. Operator 3 has two range values that are outside the control limits, and all of operator 5's range values are smaller than the operator's range values. So the measurements taken by operator 5 have smaller ranges than those taken by the other operators. Operator 3 has the highest ranges and two range values uh, larger than we would expect based on our control limit. So we should examine the measurement process to determine why this happened. Perhaps operator 3 takes measurements too quickly and as a result is inconsistent. Operator 5, on the other hand, may be more patient and focused on getting a correct reading. Now that we've looked at our repeatability variation, so let's compare that to part variation using an Xbar chart. So each point on this graph represents the mean of the measurements for a particular combination of operator and part. Again, here are operator 1's measurements on the first board. The mean, uh, the mean of the four measurements is 4.9768, and this is the first point on the Xbar chart. And this is the second point on the Xbar chart. So next we add a center line and control limits. The mean of the measurements is 5.0017. We call this value H double bar and plot our center line here. The control limits are calculated based on the repeatability variation observed in the R chart. This allows us to use the Xbar chart to compare variation in the path to repeatability variation in the measurement system. Because the control limits are based on repeatability variation, it's important to ensure that the R chart is in control before looking at the Xbar chart. If the repeatability variation is not in control, then the control limits in the Xbar chart are invalid. Because only a few points are out of control limit on the eye chart, we can feel comfortable interpreting the Xbar chart for the PCBA viewer data. So does this graph show differences among parts? Yes, many points are above the control limits, indicating difference in the part measurements. However, operator 1 has somewhat lower measurements than the other operators. So let's review. In this lesson, we use R chart to analyze the repeatability of the measurement system. We use the Xbar chart to compare part-to-part variation to repeatability. And next, we'll use the operator by part interaction graph to look at reproducibility variation. Thank you for listening.